So in this video we'll be talking about what is para-amino hippuric acid. Okay, so it is an example of secreted substance. So 90% of it is in plasma protein bound in blood. So when it is filtered, 20% of pH is filtered through glomerular capillaries and 80% is secreted by PCT from efferent arterioles. Alright, we are transporters present on basolateral membrane of PCT. So there is 100% excretion of PAH and there is no reabsorption, right? So in this way, very high amount of pH is excreted in urine. So when we look at the efferent arterioles concentration, theoretically it has to be 0 because almost 100% of pH is excreted, right, through filtration and through secretion. So when you draw the graph for this x-axis is PAH and y-axis has filter load. So as filter load increases, pH value increases in blood, filtered load also increases linearly. So when we talk about this secretion, so secretion is by transporters, and transporters get saturated in different nephrons at different levels. So there is a linear increase, but at some point few nephrons get saturated of pH transport. It means they have reached their maximum capacity, and so that's the reason they cannot further push out the pH into the lumen, and hence there is quiet bend, right, because the constant pH load is increasing. So there is quiet bend, and there is a point called Tmax where maximally all nephrons get saturated for their maximum secretion of PAH, and hence the graph gets constant as there is no further amount of pH is excreted. What happens in case of excretion? So excretion is increased, and you can see the slope of secretion is more steeper because 80% is excreted, right? And excretion slope is more steeper because it is the combination of filtration and secretion. So in this way, when we reach this point of initial of splay, at the same time there is a splay found in the excretion graph because alright, so when this point where few nephrons start failing to secrete pH maximally and pH is not fully excreted in urine as much as present in blood, so there is slight decrease, sort of bend in the excretion, right? And then there is a point where all nephrons fail to secrete maximum amount of PAH completely from blood, so excretion value decreases quite at this point. Then filtration is always constant, so the graph becomes linear to filtration route, and there is a slight splay due to the saturation of transporters. Or if secreted properly, then renal vein has pH value around 0. So there can be three effects of tubular activity in case of reabsorption and secretion. If there is some inert substance which is not reabsorbed, not excreted, then filtered load is equal to excretory load in urine, which is written as filtered load is equal to plasma concentration into GFR, which is equal to excreted load in urine, which is urine concentration of that substance into volume of urine excreted per minute. So there is no net tubular reabsorption. It happens in case of inulin, which is an exogenous substance is given, and it is an ideal for GFR measurement, and creatinine, which is an endogenous substance, which is most commonly used, as we only need to draw blood sample for this. And if 10 units filtered and 2 units appear in urine, then there is net reabsorption of that particular substance. So filtered load is greater than excretory load in this case, which happens in many cases, in case of glucose, amino acids, sodium, chloride, etc. And there is a third case where 10 units is filtered load, but 20 units appear then there is an increase in excretory load. So there is net tubular secretion, and it happens in case of para amino hippuric acid and organic acid and bases.